All right, welcome to example 2. It says so right here, still on our double angle notes, and hopefully this one won't take as long. I also again apologize for the poor handwriting. So this is a little bit different, a little bit more complicated because even though they're giving us the value here for sine of beta, which is right here, that's great, and it's asking us to find sine of 2 beta without a calculator. So what I know is the double angle formula for sine of 2 beta. I remember that from our first example notes, is 2 times sine beta. I'm probably going to always write this down just to make sure I put everything in I'm supposed to, times cosine of beta. Because really it's a matter of substitution of values into this equation or expression to get my answer. And so again, look at this. I have sine of beta right here. So I already know what this is. It's right here. I've got it. It's 5/13. So no problem there. I can plug that in. What I don't have, what's actually missing, is cosine. This is what I do not know, and I don't have cosine of beta. So I'm going to figure out what cosine of beta is using the trick you did in the warm-up, which is this is your y over your r, and cosine is x over r. And so I can use the little Pythagorean theorem down here and use the fact that 13 squared has to equal 5 squared, which is my y value, plus x squared, which is what goes on top of the numerator in cosine. That's why we did that warm-up in the beginning of example 1 notes. So if I do a little bit of quick calculation here, I think that 13 squared is 169, 5 squared is 25, and I'm trying to find x squared. So I've got to subtract 25 from both sides. If I do that, I have x squared equals, and if I take 25 away from this, I would have 144. If I'm doing my mental math correctly, and then the square root of that is equal to 12. So now I actually do know what the cosine of beta is, and I'm going to write it over here in purple. Cosine of beta is equal to x, which I have right there, 12 over top of r, which I already know is right here, is 13. And I'm good to go with one small exception. That is, look at this. I'm telling you where beta is located. It's between pi over 2 and pi. So pi over 2 is right here. Pi is right here, so it's in this quadrant. So this is in quadrant number 2. And I know that all students take calculus. So in the quadrant I care about, which is right there, sine is positive, which means cosine is negative. So this helps me determine whether the cosine is positive or negative. And now I have a substitution for both cosine of beta and sine of beta. And so I can come over here and I can actually calculate what I'm asking you to calculate by taking 2 times sine of beta, which is right here, 5 over 13, times cosine of beta, which is right here, which is negative 12 over 13. And if I multiply those, this is really over 1, so I have 10 times negative 12 is negative 120. And if I multiply 13 times 13, I get 169. And that is my answer, and that is the first problem. So now we're going to go to the second example, and I need you to pause your video and try example 2, you try 2 on your own, and then you can check the answer. So give it a little pause. Hoping you're on pause by now. Here's the answer. Same formula. I know sine. I plug it in for sine. This is giving you quadrant 3 because there's pi and 3 pi over 2, so tangent's the only one positive there, so notice how sine is negative, and I can use this to find out that cosine is also negative. Doing my little Pythagorean theorem trick, there's your r squared equals y squared plus x squared, 9. This is 4, 9 minus 4 is 5, square root. That's my top value. Plop that in place of cosine alpha, multiply across, I get 4 red 5. Multiply across the bottom, I get 9. That is your second example completed. Enjoy. I think there's one more coming at you.